Our universe is filled with wonders. We marvel at distant galaxies and exploding stars. But a new challenge is emerging closer to home. We are creating mountains of electronic waste, or e-waste. This includes discarded phones, computers, and appliances. The amount of e-waste is growing rapidly. Every year we generate millions of tons of e-waste globally. This poses a significant threat to our planet. E-waste contains valuable materials. These materials can be recovered and reused. We need to act now to address this growing concern. E-waste is a relatively new problem. It has emerged with the rapid advancement of technology. As technology evolves at an unprecedented pace, our electronic devices quickly become obsolete. This constant cycle of upgrading leads to a surge in discarded electronics. The challenge of e-waste is only going to intensify. We need to find ways to manage this growing waste stream. We must explore innovative solutions. These solutions will protect our environment. They will also unlock the economic potential of e-waste. This is a critical issue that demands our immediate attention. E-waste is not just an eyesore, it poses serious risks to our environment and health. Discarded electronics contain hazardous substances. These can leach into soil and water, harming wildlife and ecosystems. Lead, mercury, and cadmium are examples. These toxins accumulate in the food chain, posing health risks. Improper handling exacerbates these risks. Dumping or incinerating e-waste releases toxic fumes. These pollutants contribute to air pollution and climate change. Valuable resources are lost when electronics are discarded. E-waste contains precious metals like gold, silver, and copper. Recovering these reduces the need for harmful mining. Electronic devices are intricate assemblies of various materials. They contain a mixture of valuable and hazardous components. This complexity makes e-waste recycling both challenging and rewarding. Understanding the material composition of electronics is crucial. Metals are a significant component of e-waste. These include precious metals like gold and silver. They also include base metals like copper and aluminum. These metals are essential for electrical conductivity and structural integrity. Plastics are another major constituent of electronic devices. They provide insulation, housing, and structural support. However, many plastics used in electronics are difficult to recycle. This contributes to the persistence of e-waste in the environment. Glass is used in screens, displays, and other components. It is a recyclable material. But the presence of other materials like liquid crystals can complicate the recycling process. The global production of e-waste is staggering. Each year the world generates over 50 million tons of e-waste. This is equivalent to the weight of all commercial airplanes ever built. And this figure is projected to rise dramatically in the coming years. Asia is the largest generator of e-waste. Europe and North America follow closely behind. However, the per capita generation of e-waste is highest in developed countries. This highlights the consumption patterns driving the e-waste crisis. Unfortunately, only a small fraction of e-waste is recycled globally. The global e-waste recycling rate is estimated to be below 20%. This means that the vast majority of e-waste ends up in landfills, incinerators, or is traded illegally. Improving these recycling rates is crucial. It is essential for mitigating the environmental and health risks of e-waste. It is also crucial for conserving valuable resources. Section 5. Navigating the recycling nebula, challenges and opportunities. Recycling e-waste presents unique challenges. These challenges arise from the complex composition of electronic devices and the presence of hazardous materials. Overcoming these challenges requires technological innovation and robust infrastructure. One significant challenge is the separation of different materials. Electronics contain a mixture of metals, plastics, glass, and other components. These components need to be separated efficiently for proper recycling. Another challenge is the safe handling of hazardous materials. Electronics contain substances like mercury, lead, and cadmium. These substances can pose risks to human health and the environment if not handled properly. Despite these challenges, e-waste recycling offers significant opportunities. These opportunities include resource recovery, job creation, and economic growth. Section 6. Stellar Solutions. Innovations in e-waste recycling. Scientists and engineers are constantly developing new ways to recycle e-waste more effectively. These innovations are crucial for closing the loop on electronic materials and minimizing the environmental impact. One promising area of innovation is bioleaching. This technique uses microorganisms to extract valuable metals from e-waste. Bioleaching offers a more environmentally friendly alternative to traditional methods. Another promising technology is robotic disassembly. Advanced robots can be used to dismantle electronic devices with precision. These robots can identify and separate different components, including hazardous materials. These are just a few examples of the many exciting innovations in the field of e-waste recycling. As technology continues to advance, we can expect to see even more efficient and sustainable recycling solutions. Section 7. Mining the Digital Asteroid Belt. The benefits of e-waste recycling. Recycling e-waste is not just an environmental imperative, it is also an economic opportunity. Recovering valuable materials from e-waste can reduce our reliance on mining virgin resources. E-waste contains significant quantities of precious metals. These metals include gold, silver, and platinum. These metals are used in various industries. They are used in electronics, jewelry, and even medical devices. Recovering these metals from e-waste is far more environmentally friendly than mining them from the earth. It reduces the need for energy-intensive mining operations. It also minimizes the associated environmental damage, such as deforestation and habitat loss. Furthermore, e-waste recycling can create jobs and stimulate economic growth. Establishing a robust e-waste recycling sector will require a skilled workforce. This will provide new employment opportunities and boost local economies. Section 8. Black holes of recycling barriers to effective e-waste management. Despite the clear benefits, several barriers hinder effective e-waste management. These barriers include a lack of awareness, inadequate infrastructure, and illegal trading. Many people are simply unaware of the problem of e-waste or the importance of recycling. This lack of awareness can lead to improper disposal methods. It also prevents people from participating in recycling programs. Building a robust e-waste recycling infrastructure requires significant investment. This includes collection systems, transportation networks, and processing facilities. In many parts of the world, such infrastructure is lacking. This makes it challenging to manage e-waste effectively. The illegal trade of e-waste is another major obstacle. Developed countries often export e-waste to developing countries. This is where environmental and labor regulations are weaker. This practice poses serious risks to both human health and the environment. Section 9. A unified cosmic effort towards sustainable e-waste management. Addressing the global e-waste challenge requires a multifaceted approach. We need to raise awareness, invest in infrastructure, and strengthen regulations. It is a collective responsibility that demands collaboration between governments, industry, and individuals. Governments play a crucial role in enacting and enforcing regulations. This includes setting standards for e-waste management and promoting responsible recycling practices. Governments can also support research and development of innovative recycling technologies. The electronics industry has a responsibility to design products with recyclability in mind. This includes using fewer hazardous materials and making devices easier to disassemble. Individuals can make a difference by making responsible choices. This includes properly recycling their old electronics. It also includes supporting companies with sustainable practices. Section 10. Intergalactic cooperation, a universal imperative. E-waste is not just a local or national issue, it is a global challenge that requires international cooperation. Countries need to work together to share best practices, develop harmonized regulations, and support developing nations in building their e-waste management capacities. International agreements such as the Basel Convention provide a framework for controlling the transboundary movement of hazardous wastes, including e-waste. Strengthening these agreements and ensuring their effective implementation is crucial for preventing the illegal dumping of e-waste. It is also crucial for promoting environmentally sound recycling practices worldwide. By working together, we can transform the challenge of e-waste into an opportunity. We can create a more sustainable future by embracing a circular economy. In a circular economy, electronic materials are reused and recycled. This minimizes waste and conserves our planet's precious resources.